Hi, my name's Lee. Today I want to talk about taking on the costs of a dependency, about how the choices we make in our design can affect the longevity of our software projects. So I'm Lee Campbell. My background is mainly in finance. Should you listen to me? Someone at YOW thinks so. Should you trust me? No. Use evidence to either support or refute the content of this presentation. If anyone knows me, it's probably because I wrote a book quite a long time ago on reactive programming. I ran training courses mainly in the Northern Hemisphere on that. Who here is using reactive programming techniques? Only a few of us. Does it sound exciting to anyone, reactive programming? For some people, a few more hands. What about machine learning? Who wants to get a bit of machine learning? Chaos engineering? Distributed tracing? Blockchain? That reactive talk I did at YOW was 5 years ago. I find it interesting that it was pretty cutting edge then, but it still seems to be cutting edge. And I want to talk a little bit about why that is. If you're working on technology that is dated and you don't feel that you're able to migrate to new tech quickly enough, then this talk is for you. If you're struggling to achieve shorter lead times, higher deployment cadence, and lower failure rates, then this talk is for you. If, however, you're at the head of this curve, you're an innovator, you adapt, you can release quickly with good insights into your system, you might not get a lot of value from this presentation, and that's okay. This presentation isn't for the unicorns, it's for the horses. It's for the rest of us, okay? Some code bases have a short lifespan. I've worked on projects, Cyber Monday just the other week. That code was only to live just the week. Black Friday marketing campaigns, algo trades, Y2K bugs. These code bases only needed to live between a week and 3 months, and then we threw them away. Today, I'm not talking about those projects. I'm talking about software projects that intend to live 2 years or more. And with that in mind, I want to ask, how long will your software be used for? How long will it be maintained for? How long will the software that it depends on be maintained for? And how long will you be able to find developers that can develop in that technology? Interesting, we just had Kat talking about emulated VAXs and how hard it is to get macro32 programmers. So now I'm not asking you to crystal ball gaze and guess which technology is going to be relevant in 2 to 5 years' time. Is it going to be Java? Is it going to be .NET? Maybe it's Rust. But I just want you to consider that often the systems that we build will outsurvive the technology that they're built on. So how can we balance the longevity of our software while maintaining a fast time to market or a fast lead time? So I blame this book and I blame these guys. Hi, Gene. I get measured on this stuff now. Increased deployment cadence, reduced lead time, failure rates, mean time to recovery. But I was struggling. My team, we had fortnightly deployments at a 50% failure rate. So every other week we deployed, and every other time we deployed, it failed. Lead times were measured in months, recovery times measured in hours. We had code freezes. Who here has code freezes? Or knows a friend that has code freezes? Sorry. You're in a safe place, right? If you've got code freezes, if you've got deployments that take 2 hours, we used to make a cup of coffee or a glass of wine, all sit down around the desk and do a deployment. 3 of us, 2 hours to do a deployment every other week. If you're in that same place, you're in a safe place here. Like many, we get stuck with this challenge. We had to change to get some improvements. However, when we changed stuff, we broke stuff. 50% failure rate on our deployments. So adding stuff was hard, modifying code was harder, and deleting code was dangerous. So Gene seems to know how I felt. Did this slide this morning resonate with anyone? So I know that I want to have those things from the Accelerate book, the faster lead time, less failures, quicker mean time to recovery. But how do I get there? And I've found that I've been to a lot of conferences and we talked about the things that we wanted, the outcomes, which is great, outcome focus is good. But I want to know how to get there. I'm going to try and bring you along a journey and see if this can help you guys. First, let's have a look first about how we got to where we got. We had lots of issues. And I've seen this over the last sort of 5 to 8 years across different projects, so I'm going to give you the 3 things that I think are the 3 kickers. The first issue was the single repo. We get a project started, it might be a GUI, a service, a data store, and you need to show quick progress. You have to keep the stakeholders' confidence, keep the budget, and keep the initiative afloat. Then our next feature comes along, and then feature 3 or feature C gets added, and we do some shared scripts over here. But we find that the data structures are standing on each other's toes, so we split out A, B, and C in the data store. Some people start saying microservices. Still one repo though. And now we create a framework folder because we've got some shared common infrastructural concepts. And this is where I find that the wheels start to fall off. In my experience, there are 2 places that it really starts to hurt this model, this single repo. That's on your build server, and it's in your local development environment. Both the build server and your local laptop, your desktop at work, they have to build, test, and package everything anytime anything changes. Builds are slow. Even opening your IDE is slow. Anyone get annoyed with that IntelliJ indexing down the bottom while you're waiting for everything to build up? And when you're looking at the code base, you don't feel that you're in a nice little corner of the code base working on your thing. Instead, you feel like you're trying to navigate a warehouse of code. And while it's well structured, that doesn't make it efficient to work in. So you might be down here. Does this thing work? Where's my... Oh, you might be this person here thinking that you're going to work on some ViewModels. Little did you know that it was going to be injected with a mapper and a service and 3 other ViewModels. And the domain logic's all the way over there. That illustration might seem unreasonable, but when I Google, how do I structure my application, this is the guidance I get. So for a, an ASP.NET project, I get told to put my controllers in a different folder to my models, and then another folder for my views. WPF tells me to do the same thing, and this isn't just a .NET thing, Ruby's telling me to do the same thing. I feel like this breaks the law of locality that Gene talked about this morning. While it may be simple, I don't find it to be very effective. And as a consequence, focus is diluted and cognitive load is increased through indirection. At this point in the project, I feel we should be stopping and asking, who are the people that dictate the requirements, the budgets, the deadlines for the parts of our system? Perhaps this is what the code base looks like after 3 devs in 3 months, but as we're talking about a 2-year plus project and we're going to add 10 developers onto this, are we going to be able to maintain this cadence and this style of coding in 2 years' time with 10 developers? And thirdly, the other thing I think we really should ask is, do these things change together? But we don't stop. We can't stop because we have progress now. We've set a cadence that the business now expects us to maintain, and to stop for a technical rewrite would be seen as a failure. Is that familiar to anyone? You're sort of the victim of your own initial success. That spike went straight to production. So build times blow out. We stop running the tests. Anyone done that recently? I'm not going to run the tests because I don't have time. And like the office kitchen, everyone uses it, but no one owns it anymore. This doesn't feel like a movement to faster time to market. The second thing on my hit list, the way we depend on abstractions. Remember when using the new keyword became taboo? Inject all the things, right? Because of testing, right? I'm going to use this fictional class here. Like I said, I work in banking. Banks don't really like you showing their code too much. But if you work at, is it Liberty outside? This might be familiar to you guys. This is a loan class. Sorry, not this code, but the concept. All right, so at the moment we're going to focus on the validate and translate features here. We can see that the validator and translator are injected into this class. we can see that they validate a command DTO, and then they translate that. They're injected in. Why? It seems that validation of this command, of this DTO, is wholly specific to this function, this feature. It seems that translating the input, that DTO, into an internal model is wholly specific to this feature. If I was to delete the take payment feature, would I delete those two interfaces? Probably. Would I delete their two implementations? Probably. What about testing? Would I mock those out? What would it mean to mock out that validator? What would it mean to mock out that translator? I would argue we need better encapsulation than this. And it can be much worse in the real world. This is real production code. This is my one real production code thing. 11 things injected into this. I don't understand this class because I don't understand the signature of its constructor, let alone the implementation. I wouldn't know how to test this thing. Do I mock all those? If you find that mocking is a big feature of your testing, you might be doing it wrong. Taking a dependency on an external interface might seem like you're doing the right thing. For example, the interface of the Hibernate session that we just saw earlier, if you were looking closely, we took a dependency on that interface of the session instead of the concrete implementation. Now that sounds right. However, that interface, and the same with most cases, that interface will be defined in the same package or the same library as its implementation, which means I now have a compiled time dependency on that package. In Hibernate, the .NET version of Hibernate, for example, it has a collections library it uses. So when I take a dependency on that interface, I'm implicitly taking dependency on the real implementation and also its collections library it uses. We found that when we're using Azure Blob Storage Client, when we pulled that down, we actually pulled down 7 other things as well. It's the transitive dependencies. Now jQuery knows about this. It has 0 dependencies. But React, which is the flavor of the month back at the office, that doesn't appear to have learnt. When you pull down npm React, not 1 download, 17 downloads. Note, if we go back to our sample code, the developer is trying to do the right thing. They're trying to take a dependency on an abstraction. However, they don't own that abstraction. So it's very easy to forget or not even know that that I session, that's a .NET thing, they put I in front of interfaces, that I session is 900 lines of code. It's an interface definition. It has 90 members on it. So if I'm using the interface for testing, right? So I need to create a test double. So I either have to take 2 paths. I either create a very brittle test, which knows how it's been used, because there's 7 different ways you can get an object out of this session, and there's 17 different ways you can put an object back in. So I either create a brittle test which knows which one of those 2 I'm using, and then if I change my implementation to still a valid implementation, my tests might break. Or I go and implement all 90 methods. But we don't want to do that because we're supposed to test the 3 things that an ORM actually does. Properties are cascaded, so I put properties in, and properties are persisted, that updates are cascaded, and that when I run a query, those properties are mapped back out to my object. So you do what seems to be highly recommended, which is to test with the actual ORM implementation and the actual database, because there's far too much logic in your ORM not to put it under test. So we inject with an interface, we depend on an abstraction, but we always use a real implementation under test and in prod. Third on my hit list. So we depend on external abstractions, but they incur the cost of their transitive dependencies, and we can get a deep layering effect. And we're almost encouraged to do this. Adding a new package with modern IDs is so easy, but it's a slippery slope. That friendly dialogue assumes you understand the costs of taking on that dependency. Yay. So, is this what your company lays like? Sorry, I'm just going to unplug for a moment and see if this still works. Does it go? Right, we're okay. Right. Is this what your company layering looks like? This is sort of empirical evidence. I've sort of seen this around. This is what I think lines up. I have my application in my libraries. My libraries depend on probably my framework team's libraries, which have some more libraries, and then they go out and depend on public packages out in the wild. Does this feel about right? I think about 7 layers feels about right. Does anyone want to shout out a different number? 7's good? I heard someone in Brisbane shout out 12, and another guy trumped him with 20. So things like this, you've got your domain, data access, ORMs, things like that. Okay, I'm just going to do a little exercise with you for a moment. Deep layering incurs a non-linear growth pattern. So I'd like to just walk you through an example. Up the top, we've got a number 1, and that represents my application, my static void main thing. And then I depend on 3 dependencies. Those 3 dependencies is the next row, where I've got 3 ones across there. Does that make sense so far? However, each of those dependencies also depend on 3 things. So I have another row of 9 things. So my application, 1 plus my 3 dependencies makes up 4 things, and the 9 sub-dependencies, that makes up a graph, a 13-node graph. Does that kind of make sense? But I didn't say we were 3 deep. It seems to me that it's more 7 deep. So let's do some more math. Let's add that 13-node graph and put 2 more layers above it. So now I'm a 5 deep. I've gone out to a 121-node graph. But we didn't say 5, we said 7. If you go to 7, that's 1,000 nodes in the graph. If you go to 8, it goes to 3,000 nodes in the graph. If you go to 9, it's 9,000 nodes in the graph. Now that's a pathological case. NPM, NuGet, Maven, they all do deduplication for you. But there's also some baggage that comes along with these dependencies. On one project, we had the IntelliSense things, and there's other things like minified resources, images, and things like that. And I'm not too worried about a couple of extra megabytes going up to prod. I'm worried about the local developer experience. And on one of our projects, that was something what looked like what was the baggage that came along for the ride. And there's megabytes of stuff there. But there were lots and lots of projects in this microservices thing. We found that we were moving 17 gigabytes of I/O every time we did a build, with all the baggage we're bringing along for the ride. So I depend on abstractions, but they depend on abstractions, so I can get deep call stacks. Hang on, I need to drive this thing. See the business logic in the middle there? Note that that's only 2 rows. Does that feel familiar? It's funny because it's true, and this isn't a poke at Java. I've seen this in .NET, I've seen this in TypeScript. Now some might see a performance problem here. I see a bigger problem, and that's the cognitive load on the developer. The person maintaining that code, he's either or she is trying to add a new feature or debug a current problem. What about the ops guy who's reading the logs? What's that stack trace going to be any use to him? Or Troy Hunt, who's probably having an aneurysm looking at the surface area of attack vectors on this thing right now. Call stacks like that, in my experience, are far harder to understand, to maintain and reason about than shallow call stacks. And it can be as innocuous as a save method. So if we go back to our friendly imaginary piece of code, I can see 2 things that worry me here. The lack of symmetry. There's no load or get method on my session on this method. So at least 2 things know about my ORM now. It's this class and something else, right? The other thing that worries me about this is that I'm neither at the top of the call stack because someone called me and passed in a DTO, and I'm not at the bottom of the call stack because I'm making a method call out to save here, right? That's not my code base, that's someone else's code base. So we're somewhere in between, which is the scary place to be. And that leads me to ask more questions. Where does logging go? Do I log in this class Or is someone above me logging or someone below me logging? What about instrumentation? What about error handling? Do I put a try-catch around that, or is someone putting a try-catch around me? I don't really know because it's really deep call stacks. And so you end up having one or the other way you can go here, which is, well, I better be a good Boy Scout and I'm going to put logging, instrumentation, and error handling in here. But you do that on all your classes, and now you have needle in a haystack problem with your logs. It's just logs, and you can't find anything of interest. So I've been on that project before. Or you can go the other way, which is like, I'm not going to put any in, right? Which, to be fair, you end up with the same result, a not very useful system, but at least it costs less to build it. So I'm not sure which one's actually better to do. So the consequences are the cognitive load increases, I've got exponentially, super linearly with each layer we're adding. Technical freedom is slowly eroded away each time we add one of these layers. And it's like Velcro. Each little hook isn't such a problem, but when they're all jammed together, Velcro becomes a very hard thing to pull apart. So I've cut this list down to just 3 things: single repo, the way we depend on abstractions, and deep layering. But there are more. But what I find more interesting, now that we've got 3 things, is to talk about the compounding effects. So the consequences are build times, the test times, an hour left on the build. What is going on there? Test times blow out. It's 10 minutes to run the tests. What's going on here, right? To change one thing means changing all the things, so we just don't. We just keep adding. So our problem is that the code base is too large, and our solution is to only add to it. Does that seem strange? Has anyone lived in that world before? Builds take too long, so we create magic build scripts that figure out what to build, what to test, and what to package based on what changed in some Git commit. This actually introduces a new dependency, the single man dependency, the guy who knows how the magic build script works, right? The Phoenix project called him Brent or Brett, I can't quite remember, it was a couple of years ago I read it. So that's my first problem, magic build scripts. Then it's also too hard to construct things. Even with mocks, it's too hard, so I use a real IOC container, or the dependency injection container, Spring Boot container. I actually register all the real things, and then I sub out the things I don't want. And you can see when I go back to that 11 parameter constructor, how that could happen, right? I've worked on loads of projects where we did that. I think that's an indicator of poor encapsulation. And then this will be quite controversial. AOP tools like PostSharp, Foddy, Lombok, I was a big fan of them, but I'm not anymore. I found them to be just one more hook of Velcro. They slowed down my build times, which really annoys me these days. We ripped Lombok out of a Java code base this year, and it was to much debate and a lot of objection. However, once it was gone, even the objectors all agreed that this code base was easier to understand, better without it. It made debugging and understanding the code base easier with it gone. It might be different for you, but I'm just sharing an experience I had. So, complicated becomes complex. And this isn't the good form of complexity. It's complexity we don't want. This isn't the stuff Casey was talking about earlier. This is unnecessary complexity. So it can't be rationalized about our code base anymore. And we start seeing emergent behaviors, things that happen in prod that you can't replicate now on your local dev environment. Right, it's been a big day, so I just jammed this slide in for a moment. Does everyone just want to stand up? I was getting a bit tired watching an earlier session. I thought, I think we could just shake it out. Because we've still got another whole session to go after this, so just... Oh, and if you're playing bingo, something socio-technical. All right, everyone feeling a bit better. We'll get to some code in a bit, right? This is a funny thing, like I spoke at YOW 5 years ago, as I said, on reactive programming, and people kept saying reactive and microservice, Kubernetes, and it's not like the speakers all get together and agree what the words are going to be. This stuff just sort of comes out, but I'm not on the bandwagon this year, so I just humped that in there. All right, we're kind of halfway through. we've got some problems. What are the alternatives? How do we get a better way? On these projects, I found that generally the dev team knew that it wasn't right, but they weren't sure how to fix these 1-hour builds or these slow tests. It's sort of like when I go to France, I can't speak French, and then my mates start speaking French, and all I know is he can't speak French either, right? I don't know how to speak French any better, but I just know he can't either. And this is where my devs kind of felt like, we know this isn't right, but they were sort of a bit lost. They didn't have a map, so I'm going to try and offer a map, and you can use it or not use it. I think the skill here is in building systems that lower the barrier to entry, while simultaneously providing some reversibility. So let's tackle that single repo. Feature dependency is probably a better term for it. Who finds that when you introduce a new person to the team, you set up her new laptop, you spin up a local environment, and then it spews out with compiler warnings, compiler errors, tests that fail. And she says, oh, what are all they? And you respond, oh, don't worry, that's not related to our stuff. Yeah. So why are you running it then? Like, fix it. Well, I'm not going to fix it because it's not my code. So why is it in your code base? Get rid of it. And I'm not saying delete the code, but maybe delete it from your code base, move it to someone else's. From the book Building Microservices with Sam Newman, a change to one system should not require a change to another system. But Yuval Lowy was saying this 10 years before microservices was even a word. Decompose your applications based on volatility. So this is what our single repository looked like, division by technical responsibility. Note that all the things that had the same technical responsibility live together. What I'm suggesting is that that causes feature coupling. Feature A and B, because they use the same technology, they're a view, are coupled to each other. And that's not what I want to do. They shouldn't change together. Let's aim instead for division by feature responsibility. Things that change together live together. It's quite a subtle change, but I think it's an important one. Now this opens the door if you choose to move to a multiple repository style of coding. And this pattern is fractal. If we go back and remember the views, controllers, ViewModels, whatever it was before, you can apply the same pattern there. Now it can feel a bit scary. You might feel like, oh, there's another presenter standing on stage going, microservices, 100 repos. That's not what I'm saying. I think there's a guidance in the domain-driven design community. It's probably a bit better than going one end, and I do another talk about this, which is one end you've got the Lambda architecture, 100 repos. At the other end of the spectrum, you've got the monolith repo, the mega repo. I think you can find something in the middle. And that's where we find business domains, and create bounded contexts. So that's something you can Google later if it's a new term to you. And within those bounded contexts, you may have numerous services, and those bounded contexts can be your repo. So remember, loose coupling is just one end of a spectrum. We still want to balance that with high cohesion. So the multi-repository, inherently parallel to build and test, forces a discussion about design by contract, and can also reduce this knee-jerk reaction to share code. I'll rant about that a little bit later. So the lost art of encapsulation. The new keyword isn't bad. It just couples one part of the code base to another, but it does so explicitly. And this is fine. If one part of the code base should be coupled with another part of the code base, make it explicit. Let's look at a revised example of our loan class. Note here, we no longer take in a DTO, we take in a command. That's a message type that our domain has defined. My code base has defined that. Note that we have nothing being injected into us. Note that we have no dependencies that we do not define ourselves. The only dependencies we've got is the take payment command, which we define, and the transaction type in the middle of the screen there. Note that the business rules are also front and clear. I can see that I'm not allowed to create a transaction before the creation date. I can also see that transaction amounts must be positive. Okay. I can see that when the sum is greater or equal to 0, that means it's settled. Oh, all right, my loan has been settled because I paid it off. But if I pay too much, then it's marked as overpaid. I can read that. Nice thing about that is it's super easy to read, it's easy to test, and it's really fast to test. So let's make encapsulation easy, private by default. Instead of reuse being a goal, let's aim for encapsulation. Let's aim for just use first before reuse. So, hey Lee, why the hesitation to share code? I've just got lots of scar tissue from shared code. Shared code means more dependencies. Dependents don't like change. It's very hard to remove features once they're public. Semver can help, but you all know that shared code that's only used in one place at your company, right? It's in a framework somewhere and there's one class and one project and one solution that uses the framework thing. How did it get there? Some senior architect thought it was an enlightened string uppercase method that they built. If something is public, the author now has a responsibility for this, right? But if it's private, you've limited the blast radius. You now can change this thing in a local environment, really limiting what you're going to break here. So, change is hard. One guy I worked with had a thing called the snip rule. To me, this is a great indicator you probably have a good design. Here, due to technical division of technical responsibility, if I wanted to delete person 1, because I've decided that's deprecated, we're going to use person 2 now, whatever that means. What do I go and delete? Do I delete person 1 ViewModel and person 1 XAML and person details XAML? What about person up here? Is that getting used by person 2 or not? I have to finesse my way through the code base and nibble away at the leaves of this thing. What Paul suggested was, I don't want finesse to remove code, I want one branch to cut. Division by feature gives you this freedom. So, a plan of action. A domain model, or the business logic, with no dependencies. But first, a reminder of how some domains might look. The goal is to move away from these deep layers. We've got a GUI, it might send a HTTP request to a web API. That web API passes that to the domain to the framework to the data access layer to the data store, which means that we end up having a transitive dependency from our web API to our data store. That seems like a strange coupling to have. Let's aim for shallow layers. And in fact, I'm going to get rid of the lasagna shapes altogether. We're going to do away with that and have some new shapes. Let's imagine that our domain defines some ports or some contracts, okay? We've got 2 adapters, our comms adapter and our data adapter, and they're going to know about the domain, but they're going to map things to a specific technology. Let's visualize how this might work. So imagine a GUI sends that web request into our comms technology. Some of our code adapts from that technology to our domain. So that might be taking a JSON payload over HTTP and turning it into our domain contracts, or it might be taking SBE over Aeron. That triggers the domain with the message. However, the domain has made a decision that it needs to get some state. So it calls out to the data adapter. The data adapter has implemented an interface defined by the domain. And when it's stimulated, the data adapter then translates that domain request into a data store technology request. So that might be a prepared SQL statement, it might be an ORM, it might be a MongoDB query. And then the data store gets that, responds, the data adapter maps it back to the domain layer, and the model's happy. The model says, yep, save that, and responds to the comms layer and says, yes, we've got a response. So, where to start? Like an onion, we're going to grow from the inside out. We consider the core first, which is the implementation of our domain model. And we're going to continue with our loan thing. We're going to have a quick look at what a loan might look like in this kind of non-lasagna style world. I like to do TDD, so I like to sort of, I got taught this when I was still at uni, how to write out some pseudocode. So I like to do this first. What would my code kind of look like? I'd like to get a loan from a repository, I'd like to do some things on it, and then I'd like to save it. Or I could use a functional style, which is sort of a left fold state pattern if I wanted, but it's squint and it's the same thing. So let's have a look at code in action. This is always dangerous doing code on stage. Can we see that okay? Can people read that okay? Yep, thank you. All right, so we have here our loan class. It does have a base class. I'm not a giant fan of inheritance, but class hierarchies, but there's not too much in here. It allows us to pass in prior state. We're using an event source model here. Squint and ignore that, that's not really that relevant. Imagine apply event says load, and the get uncommitted events would be get state. So I've got a loan, and here's my create method. It takes in a command that we define. And I'm using structural checks here, which is a bit controversial. I don't think it is, but some people do. You can't even create my command unless it's correct. I kind of like that because you can't even get into my domain world unless you're going to give me real sensible things. I don't want nulls, I don't want your negative values, I don't want your empty strings. So that command comes in, and right there I can look at my create method and see that it doesn't support using create twice. If the version's been bumped, you can't call create again. We only support amounts between $50 and $2,000. This is a Mac loan or a SAC loan. It's under 2 years. I can see all that stuff. That's nice and clear, I think. We can disperse funds, we can take payment. Again, if we take payment, can't be before the created date. You can't do zero amounts. We know when we've been settled, and we know when the loan's been paid. So, we're isolating our business logic from our technology choices. We're actively making a decision to couple ourselves to an architectural style, in this case is event sourcing, but we're not coupling ourselves to a technology choice here. Well, we're pretty isolated. We're still on .NET. This is .NET. However, with code that I think is that easy to read, it should be fairly easy to port that to TypeScript, Rust, whatever your new cool language is. But a lot of people look at that and go, well, how does it do anything, right? I have a small orchestration layer, which I call a handler, or you could call it a router. And let's go have a look at those things. I'm just going to quickly pull up a command handler. Yay, Melbourne, you've got really nice stuff here. So I just provide an interface out to this is still in my domain, this is my little code base here. And I say, hey, I'd like a repository. I'm going to need that to be able to get stuff later. And when you call me with your command that I've defined, I'll make these calls. Note the symmetry here. My repository is a get, and then I also save with that same thing. So this is the only guy that knows about the repository for this thing here. If we look at our repository, super sweet, right? Nothing to do there. So we define our command handlers inside our domain, and if we look at our dependencies of our domain, nothing in there. Doesn't depend on anything except for .NET. All right, so what tech are we using so far besides .NET? Is this a Mongo database? Are we using Nancy? Are we using MVC? Is this Air on SB? We don't know yet. Consumers are responsible for implementing that. We're isolating our business logic from our technology choices. And here's the obligatory Jenga slide. We're trying to move away from tall, deep layering strategies towards shallow ones. Casey talked about a small change having a disproportionate ripple effect in his chaos engineering talk. I think Jenga's a nice metaphor for that. You can just give a little poke at the bottom and watch it all fall down. So what we're going to try and do is compose features together. My assumption is that's what the class that had the 11 parameter constructor was trying to do, but I don't think they did a very good job of it. So we're going to try and host shallow dependencies. So this was a hexagonal architecture later renamed to ports and adapters, and also getting a little bit of play with onion architecture. We have an app host that sits at the top, and he knows about some data adapters, which will know about the domain. So we define our ports. We'll go back and have a quick look at that. That iRepository wants one of our contracts we defined, and we might have a SQL Server one, we might have a MongoDB one. So instead of this model where my domain has a transitive dependency on my messaging or ORM serialization strategy, which can create domain models with a lot of dependencies, so that to me seems like a dangerous thing. If I want to change my logging provider, I have to go change my business code. They seem like unrelated things. I want to move it to something like what I just showed you earlier. There's no dependencies here. So far we've looked at the domain and the contracts or ports that we've defined. Now let's look at some of the adapters. First I'm going to just show you the the loan controller. So this happens to be ASP.NET MVC, something.NET Core. I'm a Java developer now, so this is sort of a throwback to .NET for me, which is great fun. I love .NET. So this adapter knows about HTTP and JSON. It's taking in a loan payment model, which is, it'll translate into a JSON, take the JSON, translate that for me. And I've put a little method on that model to say to command, and that will turn this JSON payload structure into a command that my domain understands. Now that I have that command message, I can pass that into my command handler and get a response back from that. So that's quite a simple little adapter. And the other adapter would be a SQL stream store adapter. And so if you remember, we had a repository which just had a get and a save. So now all I need to implement for my data adapter is a get and a save method. We were so brazen at my recent job to let the graduates write this because it's less than 100 lines of code. The nice thing about this is because my domain doesn't depend on anything, the tests are super fast. It doesn't have to do anything. There's minimum dependencies in there. IOC registration, I'm going to skip to this other one. IOC registration, I actually don't even have a container or in this example code base. In my main method, I define the things that I want because this main method knows how to construct the application from the constituent parts. It says, hey, I want a SQL stream store repository. I'm going to give that to my command handlers, and then I'm going to pass that to my web server. And that's the whole product. So I can go in here and follow my nose right from the start all the way through. Also note, just towards the end there, I don't have to use AOP, where are we? I've just put a little extension method that I've written, which is with logging, which just wraps that thing in an implementation that puts logging in there. So now I don't even have to have logging in my domain because I've wrapped it instead. And without the expensive AOP compile time hits. So now we've got clear places to put our logging, our instrumentation, and even our feature flags. We've got nice seams to put this stuff in. We can instrument incoming calls in our comms adapter and the data access in our data adapter. For those of you already on Kubernetes bandwagon, this might seem familiar. It might look a little bit like the sidecar strategy, right? Except without all the Helm charts and service meshes. So what's our results? Multi-repo, division of labor, cohesive code base, reduced cognitive load, and some technical freedom. Our 1 hour CI time is divided into 6 for us. I had 5 domains and 10 minutes for the shared, that took 10 minutes each, and some shared infrastructure code. And we don't have feature dependency anymore. If I want to change feature A, I don't have to ask the team in feature B. When you encapsulate, you reduce the cognitive load on the developer. They know they have a small area of code base that doesn't leak out. It does one thing and it does it well. It should also enable the snip rule. The snip rule is a type of technical freedom. While this felt like a who moved my cheese moment for a lot of the developers, we were able to release features faster, more safely, and in an independent manner. Another thing we did, we don't have the container involved in our tests anymore. We don't have the IOC container. That interestingly halved our test time. That took our 10-minute builds down to 5-minute builds. Seemed bizarre to say earlier in the project that we could get our 1 hour build times down to 5 minutes, but we just did it. Inversion of dependencies. I believe this is what the original intent was, defining our own dependencies and having them injected. And I found that to be a great way to keep the code focused. The design almost forces encapsulation, enables shallow call stacks, but most importantly, it's an enabler for technical freedom. I found that this also further reduced our CI times because you end up with just the code you need, not the baggage. Any pull request that adds more baggage, it's so obvious that you can reject it right there and then. And these concepts are fractal. Code layout, encapsulation, the ports and adapters pattern. It works within a library at a class level. It works within a repository at a package level and works in a deployment at an API level. So, to wrap up, every dependency you add to your system adds a cognitive load for the people using the system. While small, each one of those is a distraction from the job at hand for the developer. Loading all that knowledge to get up and running adds friction. I think there's a high value in having a project that's so boring and common that you can just reach out to ThoughtWorks and say, hey, I'd like to have some developers for 2 weeks. They come in and they sort it out and then they're out the door again. That gives a lot of economical freedom to your business. Less dependencies they have, the less routes you have to pull up anytime you want to pivot one way. You still want to be using in Hibernate or SQL? How hard would that be to move to Event Store and NoSQL? All this comes back down to time to prod. How fast can a profit generation unit ask you for a feature and realize that profit generating capabilities? There is a happy ending, by the way. We release multiple times per day now. That fortnightly thing's gone. So we're doing I think we're doing 4 deploys right now back in Perth, and we're measuring it at about a 2 to 4% failure rate, down from 50%. So we're pretty happy. For many of us, this probably is the start of the conversation. Feel free to reach out to me if you want to continue it. Thank you very much.